what I'd like to do is actually sort of ground or embed the discussion of telematics in the larger discussion really about smart communities. And I think telematics and sensorization is really a part of a larger movement, which is how do we use people and process and technologies in our communities really to build better and smarter communities. And so that's I really want to sort of start there, and then we'll move into some of the discussion relating more specifically to how we use GIS and telematics really to power greater efficiencies in our operations. So let me start. I mean, probably we now have smart beds, we have smart refrigerators, we even have connected and smart pets. So I mean, it literally just about everything that in our society is now quote smart. And as our president Jack Denjman once said, no city wants to be thought of as a dumb city. Everybody wants to be a smart city and a smart community. But the real issue is what do we really mean by that? And in a certain sense, it's almost become kind of an overinflated term. So at Esri, we really think that there's four key critical components or tenets that really help define a smart community, whether it's a city, a county, or a state. You're going to hear from a state DOT today, but there are really sort of four elements. And one is, how do we use good planning and engineering practice to really build more vibrant and sustainable cities? And secondly, how do we really improve our operational efficiencies within our communities? So how do we use real-time sensors? How do we use telematics, to bring together so that we can continuously improve our operational efficiencies and our operational performance? And then we need to be able to understand how we can use data, and in many cases real-time data, really to continuously improve our performance. So how do we data-driven performance? And so again, that's a third key component. And then finally, civic inclusion. And that's really how do we better connect with our communities, and how do we also do in a way that with an emphasis on greater social equity. So these are the four components, and I really want to spend a little bit of time looking at sort of good examples of these components in various cities. So again, we start with planning and engineering, and really that's what we mean by that is how do we in our community take an approach which really tries to build a vibrant and sustainable community, one that's really can adapt to change. And certainly, I think most of our communities over the next span of time, we're dealing with climate resiliency, we're dealing with a whole range of challenges. And so how do we really apply the best technology in ways that help us meet those challenges and really build vibrant cities, and such things as green infrastructure and really having a human-centric approach to really building our cities and applying best practice. So let me give you a few examples. This is actually in the greater Detroit area. The cities, together with the several of the airports, banded together and really looked at how do they build a larger community, which is really based around just-in-time delivery and being able to take advantage of emerging technologies like UAVs. So in fact, they contracted with a company called Airspace Link, and they really helped to define really the next generation, really the next transportation networks in the greater Detroit and Dearborn area. And so using land use data and a variety of other GIS-based data, how do we define those future corridors? And in this particular case, how do they really facilitate that delivery of inputs to really just-in-time manufacturing and really using technology to sort of rejuvenate and really build the next generation of communities in the greater Detroit area. So again, how do we look at these technologies and how do we begin to plan for the future? Similarly, here in Southern California, we actually have a city, the city of Ontario, that again did really pretty much the same thing, working with a major developer. They really designed the first drone-enabled or drone-ready communities such that literally you can have drone deliveries of food, of groceries, of a wide range of deliveries directly to your home. And again, working to define these future networks. So how do we understand where we're going in the future? And it's not just drones, but urban air mobility. We're really talking about a time frame within the next 5 to 10 years in which we're likely to see what are often called urban air taxis. And so how do we make sure that we define appropriate corridors for these types of vehicles? And so again, using the technology really to look ahead and how do we plan for a smart community. Another example, this one taken from Eau Claire County and Wisconsin. And historically, cities have often used interns or very manual labor to go out and to collect all of the asset information that they need really to power their asset management systems. In this particular case, then the Eau Claire County really contracted with one of our business partners, Manley Communications, and in a very cost-effective and fairly cheap way, you can see the vehicle there, and they're really collecting both 360-degree digital video together with LiDAR, and that collects a very accurate picture of all of the roadway assets, everything from signs, gutters, pavement markings, etc. And then doing feature extraction, that really creates the asset inventory that is drawn into the GIS and then actually goes into the asset management system. So a much more cost-effective, cheaper and faster way of collecting all of that information really that powers our asset management systems. And you're going to hear a little bit later, CompassCom has a relationship with CityWorks. So again, how do we really make seamless flows from data collection into our mobile workforce management and to our asset management system? So again, really being able to use technology in very smart ways. Most communities, most cities really sort of grapple with the notion of micro-mobility. We have scooters, we have, in many cases, we have multiple brands of these scooters. We have bicycles, we have any number of other types of micro-mobility systems. And the real issue is that how do we, one, ensure that they're used appropriately, that they don't just simply clutter our sidewalks, but also how do we ensure that there's equity in terms of service across our communities. So the city of Nashville is one that, again, is really sort of monitoring. They insist that all of those micro-mobility providers supply that data so that they can actually track all of those movements we understand where all of those systems are located, where they're being used, and really how do you use that information then really to feed into your larger traffic management system so that, again, you can improve public safety and that really you have a better understanding of the urban mobility patterns. And so, again, the ability to bring together this sensor information, analyze it, and really then use that to make better decisions in the community. And then finally, I want to point to this. This is actually in the San Diego area. This is the Metropolitan Planning Organization, and probably had one of the most far-reaching and I would say one of the best sort of longer-range plans in terms of how do they transform the transportation in the San Diego area. And so they really had 5 components, and they actually did talk about the next, they called it the operating system. In fact, they're really pulling together a lot of real-time information, building patterns of use databases around that, so that to really help them better plan for the mobility of the region and creation of complete corridors, new mobility hubs. If you haven't seen this, I would encourage you to really sort of take a look, and you can simply Google SANDAG long-range plan. Really sort of bringing together a lot of both real-time information as well as historic information to really look at, and how do we better understand our mobility patterns, and how do we use that to really plan for a more successful future. So I think all of these are really examples of how do we apply best planning practice really to making our cities smarter, more livable, more sustainable, and really more responsive to our citizens. So as I always say, you really can't be a smart city unless you're really solving your mobility issues. And certainly these are great examples of the use of, again, technology and looking at process and how do we bring those together really to define and design better and smarter cities. The next big area really is operational efficiency, and that's really where the fleet management, telematics, and really the sensorization, so that how do we bring together a great deal of information in real time to make better decisions, to improve our operational performance. And that's really again, a key tenet of sort of transformation of cities, if you will. So any number of examples. We're going to speak a little bit about Cobb County and their traffic management, their use of artificial intelligence. We have such things as wastewater monitoring for both opioid as well as COVID monitoring, a wide range of cities and communities really bringing together that real-time information. And we do think of, as Brent mentioned, these are systems of systems that really help us better manage our cities. And then we're going to speak a little bit about the Iowa DOT and their snowplow, their snow operations. So we'll see. So Cobb County is actually monitoring a great deal of not only vehicle data in real time and pedestrian data, and bringing all that together in ways that really feeds into their traffic management and their traffic operations. And the real move among any number of cities is how do we capture that real-time information to then help feed into our dynamic signal control, and so that we actually can adjust our signal timing and our signal control systems based not just on historic data, but actually on real-time traffic patterns. And so that's certainly been the practice in Cobb County. city of Raleigh is, I think, a great example of that really kind of sensorization or the instrumentation of a city. So not only are all of the municipal vehicles, everything from the trash trucks, the smart parking, literally the trash receptacles are sensorized so that rather than sending a vehicle around to empty those on a regular schedule, the trash receptacle actually notifies the city when it's full and when it needs to be picked up. And again, very similar, all of the micromobility. So all of that is really brought together. And the idea is that, again, how do we use all of that real-time information to better operate and better manage our cities, and having that real-time common operational picture, that situational awareness helps us take greater control and really make better decisions. So in the case of Raleigh, they're actually using machine learning and AI so that you can actually see capturing that real-time information, not only vehicles, but also pedestrians and trucks, and feeding that into a system in real time. So again, using that information for dynamic signal control and further really sort of better understanding the mobility patterns within the cities so that, again, we can better plan. The Iowa DOT, and this gets a little closer to the focus today. The Iowa DOT has long been, I think, a leader in terms of not only sensorizing and putting telematics on their snow plows, but actually pulling a great range of data from those plows, putting them into dashboards for analysis, and in fact, looking at the past year's plow patterns and the material spreading, are actually able to reanalyze that data, understand how they could do better. And then even more they actually publish that data out to the public. So they let the public really know the cost per segment of highway of keeping the roadway clear. So that, again, it's that, how do we communicate? How do we effectively create that dialogue between the public agency and the community? And I think this was a wonderful example. You're going to see another example from Illinois DOT and their dashboards today. So I think this is really a strong movement towards not only how do we better understand the performance of our snow operations and how can we be more efficient, more effective, but also how do we have greater transparency with respect to the public. So again, I think this is all part of that larger, really sort of smart communities. So again, how do we really look at, how do we bring together technology and people and process really to the betterment of our communities? And I think that's the larger context that we really need to help understand the examples that you're going to see today, and the larger effort towards smart communities. So there's really sort of, I think, two critical components, and one is the real-time GIS. How do we, whether it's telematics, whether it's a variety of other sensors, how do we bring that real-time information into a GIS so that we can analyze it on the fly, and then we can use that information really to help us make better decisions, whether it's in public safety, whether it's in public health and public transit, and public works, airports, etc. We have the ability to increasingly bring together just a tremendous amounts of real-time data. And the second part of that is that what we really need to do is we need to look at the full workflow really of our field operations. And so how do we bring that real-time information into the GIS in ways that will help us better plan and better understand, better monitor, and better coordinate the activities of our field workers. And that's really, I think, the challenge is that it's not just to see our snow plows or our utility vehicles or our inspectors on a map, but it's really how do we look at that entire workflow and how do we understand how we can better coordinate it, better plan it, and better understand so that in fact we can continuously increase our performance. So it's not just the real-time data, but it's how we bring that in and how we use it to make our communities smarter, and really how do we continuously increase our performance. So a couple of examples here, and these are just really designed as illustrative, really looking at long-haul trucking in this particular case. We can actually see the origins, destinations, we can see different terminals, we can understand particular driver behavior. Are they en route, out of route? We can overlay weather information, we can understand their loads. All of that information can be brought together in real time in ways that really help us better not only monitor, but really how do we improve that performance over time. This is another example, and this is really looking at how do we not only monitor particular vehicles, but really the health and the status of what that vehicle is doing. So very similar to examples that Brant mentioned in terms of snow plows, this particular case, and drilling operations. So we actually can understand literally the health of the vehicle, and literally the performance of every one of those vehicles, the drivers, and really monitor that in real time in these types of dashboards. Certainly we work with just about all of the major trucking operations, and location and telematics is really critical to their performance, as this particular example from Old Dominion illustrates. They really found that by being able to bring that real-time telematics information into really a common operational system, that they could then improve their performance, and they could really understand when they had issues and could respond really in real time. And so these are the types of systems that are fairly ubiquitous among the major trucking operations. Another one, actually, Cisco has global service level agreements for all of their hardware. So we have worked with Cisco to help them not only understand where they should have their centers, their repair and response centers, but also how they can route and how they can actually respond and meet their service level agreements, and to do that literally globally. So again, it's that ability to understand, have that common operational picture in ways that really helps them improve their performance, and in this particular case, to meet their service level agreements. So I'd like to sort of finish with that, and again, kind of re-embed, I think that the examples that you're going to hear today, great examples from CompassCom and their customers, are really embedded in that larger notion of how do we really use real-time information really to build smarter and better communities, really by leveraging those four tenets of best practice in planning and engineering, operational efficiency, being able to use data more effectively to really help drive our performance, and how do we create those more engaged and more transparent cities. So with that, I'll go ahead and I'll finish up. And I want to thank Brant for the invitation today, and I look forward to seeing the great examples from a number of Brant's other customers.